You're probably wondering when 13.1 and 2 will end. I am as well. But here we go. Factored form. This is probably part 4. The factored form of a quadratic looks like potentially an a. We could always have 1, so the a is not always there, but you've got your two factors. You've got your x minus m and your x minus n. And if you ever get it into factored form, it is nice to see your x-intercepts in that way. And the x-intercepts are m and n. And the reason why is if you were to put m into this equation, this entire parenthesis would turn into 0, causing everything to turn into 0, and you'd get an x-intercept. And that's why they're called zeros or roots. I will show you how this is going to work with example 5. So what it says is to factor this equation, then use the factored form to find the x-intercepts. The first thing I'm seeing is there is a greatest common factor in each of the terms. So the first thing we'll do is we'll take that out, and that was a 2. We want to continue to get this into its factored form. So I'm just looking at that trinomial. I'm doing my work off to the side. In this case, I don't need the AC method, so I just need the regular box. I got to think about what makes negative 24, but adds to make 5. So I'm thinking about my factors of 24. 1 and 24, 2 and 12, 3 and 8, 4 and 6. All right, 3 and 8 make 5. And I want it to be a positive 5, so that means I'll have the 8 be positive and the 3 be negative. So now I have x plus 8 and x minus 3. And this first term, that 2, is positive. What that would mean, didn't ask me, but I could tell you anyway, what that 2 would mean is that we would have a parabola that was concave up, and now we can also find our x-intercepts. We can set each of these equal to 0, and we've done this a few times in this class. Minus 8, so we'd have one x-intercept at negative 8, and we would do the same thing for the other one. And we'd find that our other x-intercept was at 3. Instead of saying solve for x, it said what was the x-intercepts, and so the x-intercepts are values, points, and so we would have negative 8, 0, and we would have 3, 0 as our answers. All right, I want you to try the same thing. You're given a trinomial to factor, and then look at those factors to find the x-intercepts. If you want to check your work, a great way to check your work would be to put those numbers into the equation and verify that you get out a 0. I will show you how that check might look. So let me just get a little bit of space here. So I'm going to put 3 in as an example into my original equation and see if I get out a 0. And now we're getting 48 minus 48, and so we're getting that f of 3 equals 0. So that one checked out, and you could also check the other one if you'd like by replacing those 3's with negative 8's. And if you put in negative 8 as your check, it would have looked like that instead, more or less. Okay, so go ahead and try that.